How do you measure the area of a shape with a curved edge? A rectangle is easy, a triangle fine. But a curve, there's no formula for wiggly. The trick people found is almost absurd. Cover the curve in rectangles. Rectangles you can measure, then make them so thin there's no room left for error. And doing that reveals something no one saw coming. Watch. Straight edges we've handled for millennia. Length times width, done. But nature isn't made of straight edges. Orbits, growth, the path of a falling drop. They curve. And the space under a curve had no clean answer. So here's the move. If you can't measure the curve directly, approximate it with something you can. Rectangles. Slice the area into thin vertical strips, each one almost a rectangle. Add them up. It's close, but not exact. There are little gaps and overshoots. Unless you make the strips thinner. Here's where it becomes beautiful. Make the rectangles thinner, and the error shrinks. Thinner still, smaller still. Push that idea all the way. Infinitely many rectangles, each infinitely thin. The gaps vanish completely. The staircase becomes the curve. And the sum of all those slivers stops being an approximation. It is the area, exactly. That's the integral, not a formula to memorize. A sum of infinitely many pieces, so fine that nothing is left out. And now the part that stopped mathematicians cold. Remember the derivative? Zooming in to find a slope? Finding area seems like a totally different problem. Opposite even. But they are opposite in the exact way that undoes each other. The derivative cuts a curve into instant rates of change. The integral adds those pieces back up. One takes apart, the other rebuilds. So finding area and finding slope turned out to be the same question, asked from two directions. That link has a name, the fundamental theorem of calculus. Two problems 2,000 years apart, secretly one. So the area under a curve was never unmeasurable. We just had to stop looking for one clean formula and start adding infinitely many tiny ones. Cut anything fine enough, and even a curve gives up its secrets. No more excuses. See you at the next theorem.